Well, we are. Let's see. Yeah, well, that's a good thing. I did a Pachuca talk last night. Bad attitude is cleared up those bad ones.
Is it fun?
With the presenter? I don't know, when my heart starts racing, I wondered about that. Good morning. This is IDR. No, you didn't wander into the Pachuca. We may have bad attitude, but we try to take it to our protocol. John will go through the note well.
Since this is either your last or second last meeting of the week, you probably have seen this about a bazillion times. But you know, this is your meetingly reminder that the IETF has fairly specific definitions of what a contribution is. It's a pretty broad definition and generally covers, you know, all the stuff that's on here. Things you say, things you email, probably covers interpretive dance if you choose to present in that format. And if you haven't ever gone and read this stuff, it's boring but important. Please do.
The other favor I had is with all presenters, please check the slides that are online. We found a bug in the meeting manager, and I uploaded all the slides again this morning. If I have made a mistake, it is of course my mistake. Please check before your presentation so we know if we have to pull something down, and we've got 2 laptops. So I'll be watching mail. Thank you.
So we have an agenda. I think we don't need to read the agenda to you. We should rather just get to doing it. It's a pretty full agenda. And without further ado, Sue, here's your clicker.
One more, John. I put the extended miss. Yeah. Okay. You can read all the rest of the agenda, but this is probably something we need a sense of. The AD kickback extended messages to us, not necessarily due to any significant technical problem, but a significant technical question. And I think I put that on the list. The option that was originally in there was only updates to go to the larger size. The option 2 is all messages. And then the option 3, which seems to be winning in the, is all messages, but restrict, and in another part, be open to 4096. Randy?
Randy Bush, IJDRL. As a disinterested party, I really don't give a damn. The third could also be open 4096, reopen Piggy if
Yes.
you got the consensus for large, because somebody was whining that they had something they wanted to say in open that was fatter
That's
than I
true.
am.
And probably, John, are you next or no? Okay. Is there any comments, or John, you're taking your mic moment?
Yes, I'm John Scudder, working group member. Yes, we could do any of them. I think that my own preference is option 3. I mean, basically, I think if you want to restate option 3, it's you know, 64K for all messages, but don't try too hard with the open. You know, you don't have to go to heroic lengths to get the open just exactly perfect. And at this point, I think we should say, you know, perfect is the enemy of good enough, and let's just do good enough.
Yep. So this is a moment for discussion. If you have some strong opinion.
Randy, again, I have a strong opinion on one thing. Open, fail is not reasonable. In other words, if you try the open and you cannot, whatever options you've chosen, negotiate, failing is just operationally not useful.
Okay. So this will go back to the list. Any more discussion in person? Good. By the way, I'm hoping to run through all my administrative stuff so I can give some more time to the folks. So don't be shy about getting to the mic list, because we'll go on quickly. And if you finally get out and get to the mic list and go back, that's fine too. Go ahead, John. So as part of my chairly duties, I wrote up some options for registration. We had some really fun discussion on the list, but I'm going to go through a couple. Just a summarization. The first is the problem I perceived, and it might not be the problem, is we found squatting on the attributes and attribute errors in the allocation. The following solutions were listed on the list. Thank you everyone for contributing. Deprecate the squatting on attributes, which we did. Public shaming, which happened. Tooling, thank you, Joe, for suggesting that. To check drafts for attributes. Quicker early allocations. One was go to first come, first serve. Forget all this nonsense about allocation. And then my last, the draft is how you might instrument the better reviews for early allocation or working group last call. This is an open call for further comments, suggestions, hatred, food fights. I love doing this early in the morning. It's so much.
AC Linda, it seems like when the current early allocation policy is used, it works. It's just cases where it hasn't been used that people have ended up with code with attributes that weren't allocated.
Okay. Anything else? Oh, I did forget one other thing. It is our intent to go forward with the BGP model. As soon as it's revved, I'll chase that. If anybody's interested, wants to make comments about it, come see me. I'm not going to use working group time unless there's a rush to the mic. Alvaro, did I do everything I'm necessary, or should I make a better call? Okay. We've got a lot. Okay. If we had registry, my significant point is we shouldn't delay any draft. If we do any extra review, it has to be done during last call, and the people who are reviewers have to be aggressive. Okay, you can read that. We're going to skip it. I think, John, either we've got 2 copies.
We might have.
Nope, there it is. Nope, you had the right amount. I put stuff at the end of the deck. Okay, deprecate atomic aggregate. Okay, this is going to show that I have a faulty memory. Why did we do atomic aggregate? I had to go back and recreate thanks to Shiram and Jeff and several people to help my memory jog. Why did we actually create atomic aggregate? We created it because if you follow this methodology where you aggregate routes with various Deus class and you get a prefix in AS set, if you don't mark it, or if you just aggregate it and give a new AS, we found that there were loops that was, I think 90s, 87. Whenever we were doing RFC 4271 and its predecessor 1771. In my discussion, part of it is to look and see if there are any sets in the internet. Statistics seem to indicate they are. It seems to indicate we still have the situation. So I really want to take a deep dive before we do that. That's, excuse me, Sue Hare's speaking as working group member, co-editor of 4271. I think we got to dig a little deeper. It's not just its craft. We got to dig and see if it's still preventing situations. So I'll work with some of the researchers. If you have interest in this topic, chat with me. I was real fascinated that we might have a better BGP stream to look at that. I mean, the guys from CADA have got some more tooling. Questions about this? Some of the circumstances that the route leak people have, we found as early as 1987 in the first deployments as BGP, and unfortunately, Rudiker, we both may retire before we finally get it fixed. But there's both route leaks, but this aggregation plays into route leaks and cause some of the atomic aggregate. It was a fix because all it does is put a flag in there so you can detect an AS loop. Doesn't really fix the rest of the problems. Job, thank you for that question about whether atomic aggregate could be deprecated. Good question still. How come you have all these good questions? It's really great. Other questions about atomic aggregate? Those were my chair's to-do list. Okay, I love it. We're ahead, aren't we, John?
We are.
Okay.
Good morning, I'm Jeff Haas, and I'm here to talk about updates to the route server for BFD spec. So this is just a reminder of what we've presented on before. Route servers are used at internet exchange points. The internet exchange points have some form of switching fabric, which are based on various technologies over the years. And unfortunately, a side effect of those switching technologies is, despite the fact that the route server clients, which think they are attached to something that resembles a broadcast segment, actually are in something that effectively is non-broadcast multi-access. And a side effect is occasionally you lose reachability to something that the route server tells you. So this means that since they're not learned directly from a BGP peer, it is not possible to use BGP timers to have the sessions time out and black holes to result as a side effect. And this is just basically saying exactly what I was saying. Top picture, what happens if you have real BGP, and of course, the bottom picture not only is route server environment, but also any sort of BGP third-party next hop environment as well. The solution that we're putting forth is basically to use BFD to test the reachability of the BGP next hops. Very simple. Once you have a BFD session to the next hop, if you lose reachability, you can treat it exactly as if the next hop is no longer resolvable in an iBGP situation. We know what BGP does in that situation, so this is the simple part of the proposal. We won't spend a huge amount of time here. The problem that we do also have in this environment is not the BFD piece, which we think might be usable in other circumstances. It's when you're using a route server, the route server may have alternate paths that it could give you to allow you to receive alternate reachability in the case that you can't get to your first peer. But the problem with that is that you have to inform the route server of that circumstance. And the churn that we've had in the last several versions of this draft has largely been, how do we actually inform the route server? In the general case, we've been staying with the same set of technology, same set of core concepts, but the actual delivery technologies change. We're defining a next hop information base, which just basically says, I'm tracking this. Realizing the terminology set from 4271, we have a adjacent next hop information base in and out. And important part here is what you place in the next hop information base will depend on your perspective. Are you a route server client or are you route server peer? General procedure for all the mechanisms we've been doing is that the route server is going to tell its clients about the next hop that it knows about in its RIP. This is basically the set of next hops that for a given rib out for a route server, which might be a logical view, that set of peers would actually peer to track. This does also mean that we actually have to put in the BGP peering addresses if we don't actually have that next hop available, mostly because since BFD is going to be using it as the tracking mechanism, we require both sides to actually be prepared to set up the session, even if the route flow is asymmetric. The route server clients will set up the BFD sessions based on what they receive in their NHID in, and once they actually have that and have established BFD and know exactly what's going on, they'll put it in their NHID out to tell the route server. So what's really changed here, and this is sort of a short history of what we've gone through in the draft. We originally tried to use the NH cost SAFI to do this job. Turned out to be not exactly a good fit, and it was pretty close, but the semantics were just a little bit off, and we didn't want to overload it. Hannes had actually recommended using BGPLS, and this actually was a great fit. The problem is that the feedback we got from people is, great fit, yes, complexity is way too complicated for the application space in question. And 03 that's just been published, we've basically gone back to something resembling the NH cost SAFI that just simply is a new SAFI that you use to exchange the next hop information base in and out views. Very simple SAFI. What's come up since we've actually published the newest version is some good discussions about things that we need to change. Very specifically is that the model that we're describing is probably a little too complicated. John Scudder is suggesting that we have effectively two distinct views of things. One from the perspective of the client, one from the perspective of the route server itself. So the next rev will go through, tear things out, and simplify the terminology. The actual procedures don't change, but we're just trying to make this much more understandable. Also, the current proposal leaves basically negative state into the route server because we advertise that it's up, and then you have to deal with the fact that it's told you something, but it's actually down, and you need to flush things to make sure that it actually disappears. John's actually got a new proposal that will be coming out at 04 that basically leaves us only positive state and should simplify this mechanism too. And really the last thing that's needs to be done is this has been through 3 distinct hands of editorial styles, and it's a little bit hard to read. We'll be cleaning it up in the next round. Question, Tony.
Tony P. Just one question. Who is dealing with BGP or BGP? Client or server in this case? Because then you don't need BFD, right?
So the problem is this is a route server. So my BGP peering session
Never
is to the route
happens.
server, and everybody's talking to the route server. You don't have direct BGP to the clients in most cases. Although the thing we're being told for the exchange points is you do occasionally have real BGP sessions. But in that particular case, you could still use the BFD component, but you don't use the next hop tracking piece.
Okay.
So I have not been following this discussion very closely. So I have a very sort of naive question. Can this be done without involving this changes to the route server or BGP spec? Because certainly when you receive the update from the route server, you know the next hop addresses. So so the client can actually keep track of that, bring up the BFD sessions. And if the BFD session goes down, you basically mark these routes as unreachable and still retain them. And after a while, if it comes back, you can reuse them. So what I'm missing?
So the 2 things that you're sort of missing from the discussion is, and that was Anchor Chen for the notes. The 2 things you're missing is that you can learn your next hops from for the peer, but the other side also has to know about your next hop to set up the session. If you have asymmetric route flow through the route server, that might not happen. So that's thing number 1. Thing number 2 is that you want your BFD sessions to ideally be pre-provisioned, even if they're not up. You want them to be able to come up quickly, and that's another reason why you hear these from the route server ahead of time. And as a side effect, you also don't want to churn your stuff based on next hop reachability too much. Obviously, you can apply hysteresis and just hold on to what you last learned, but it's better if the route server just sort of helps you out with that. And the third detail is that we're trying to tell the route server something's gone unreachable, specifically so that it can, if it has a backup path that's not advertising to us because of route preferences, by telling route server that this next hop's not reachable, the backup path can be sent to us instead.
I see. So the third one is that in case of backup, basically, the route server will be run through policies.
Exactly.
Yeah, the first one I got it. I think basically, let's say you have you receive routes from the route server for another client, but you really don't advertise anything, so there's no next hop. Yes. Thank you.
Job Snyder's NTT. Perhaps this has already been addressed on the mailing list, but if this mechanism would fully depend on add path, you wouldn't require the clients submitting state back to the route server because the route server wouldn't need to know. Has this approach been considered, and what were the pros and cons?
So we did discuss actually using add paths in a different context, not for the specific draft. So the first mechanism of tracking things through BFD, we think is still valuable regardless whether you're using add paths, and that route asymmetry is really still a problem here. If this was somebody doing peer-to-peer over the exchange point fabric, that's obviously not a problem. You could simply use normal BFD to track this or double engagement timers. But in the case of a route server, you want those backup paths. You could do add paths. The feedback we got from the add paths for route servers draft that we have is a different thing, is that a lot of edge devices don't necessarily speak add paths, so that's not an option in some of the cases. In some of the cases where it is valid, inter-route server behavior for making sure you have the full set of paths consistent between both route servers is the other part of what that draft is attempting to do.
On the flip side, we might be able to expect that by the time this has running code, that add paths is also more widely supported. I mean, which will come first in our deployments. And I think since add path is older, it's likely to exist on devices that would use this mechanism. So I'm not sure if I would exclude it as a mechanism.
And we're not. Like I said, the BFD piece is still of use no matter what.
Correct.
So, and unfortunately, we still need to channel back to the route server to learn the next hops and questions to have consistent BFD programming. So even if the next hop, if the route server does not use this information for anything, just throws out the BFD state, we're still getting benefit. There are no further questions. I return some extra time to the chairs.
Alexander? Thank you. And if Randy's joining you on this, okay. Please do a couple forwards and make sure I have the right one in the right place. Does that look right? Okay.
Alexander Azimov for the labs. And today I'd like to discuss with you mechanisms of leak prevention using roles.
Just a minute. How many people can hear him? Good. Okay, move the mic a little up. Yeah, or hold it.
Is it better? Okay, so let's go. As you may notice, we split our draft into two parts. First one covers roles and IOTC attribute. So it covers route leak prevention. Second one covers IOTC attribute only. So it's more about the route leak detection and filtering. During this report, I'm going to focus on the first part and discuss questions that were raised in some private discussions and in mailing list. First one, and maybe the most important one, is the partial deployment. So the question is if we should use role settings if they are not checked by the other side. So if you are using roles, the other party is not using, should we still use IOTC, EOTC, or any other attributes? I have 3 points here. First one, the absence of filtering in any cases is the worst case. So you will never be able to create a configuration that will be worse than absence of any filtering. Second, from my standpoint, roles are much more native than communities plus route maps. And I expect that the number of mistakes configuring roles will be much more less than compared to the current state. And the third point is a proposed strict mode. In strict mode, your session will be established only if the other party supports roles and send you them in open message. It could become a really good mechanism of motivation to implement this BGP extension. And I could easily imagine a IX that will give a statement. Our route server has no leaks inside. So just connect and there will be no problems. So, and here we're moving to the next question. What peering roles are for IXs? It's common to think that we peer with route server. But in reality, if we dig a little deeper, we'll find out that route server provides us a service of local or not very local connectivity. And so route server, it maybe sounds a little odd, but it's a natural provider, especially in case when a route server also adds its autonomous system in the path. So route server also has a perfect place for implementing these extensions, and also if at some point there will be also implemented EUTC or ILP, it will be also a perfect place for route leak detection. So there is a set of questions that we, authors of this draft, would like to address to you. First one is, do we need to add clear statement about roles of IXs in the draft? Second one is about complex roles. We're not pretty sure that we really need them. Maybe a good way is not to have complex roles and finally remove ad hocs that result in different peering relations at the same BGP station. Split BGP stations, split peering logic, and that's all. And the last question is if IDR finally wants to adopt this working item. So, thank you.
Randy Bush, IJDRL, co-author. I'd like to speak against the complex role. For many, Gow Rexford speaks of valley free and peer flat. And for many years, I've argued against Gow Rexford as the iconic model. And recently, Philip Gill and crew did a study showing that it only holds in about 65% of the cases of ASs. But that doesn't mean that complex is common. What it means is there are a significant number of people that do not up-pref customers, okay? And I think complex is very rare. The people doing it, like all the rest of us, are supposed to be smart and careful. Of course, they're not. But complicating protocols to take account of 1% cases, I don't know. I'd rather fix the major part of the problem. That's just personal feeling. Love to hear from somebody else who wants to speak to the issue like Doug.
Oops, sorry, Doug Montgomery, NIST. So did I understand correctly that what your one suggestion for an alternative to complex is just to run multiple sessions?
Yep.
Sorting out the multiple roles?
Yeah, that's the idea. So different peering logic, different BGP sessions.
Randy again, and I think that is fairly common. The big case is people who give you local peering and global transit, etc. Maybe someone, that's certainly what we do, is run 2 sessions. I don't know, Yob, you care to speak to that? You run 2 sessions? Wednesday and Friday.
Oh.
Any more questions? Okay, so thank you.
Can I ask how many people in the room have read the draft? So, sort of, are a few hands sort of timidly popping up? I mean, that's okay. I would, it's not that big of a draft. It's a relatively important topic. I would like to encourage people to read this thing so that we can have a meaningful working group adoption call, since we do now have a request for adoption on the table. Thank you.
I'd like to take a moment just to introduce Ji Dong. Ji, will you stand up so all the people who requested seeing your slides? Ji Dong has gracefully, stay standing for what, he has accepted being the secretary, and many of you who sent in slides were the chairs. John and I are very grateful that Ji has been agreed to help us. Thank you.
Good morning. So this talk fills in some of the additional details following on the previous talk. Next slide. So just a quick intro to route leaks. We already have a RFC 7908, which provides the complete details about route leak problem definition and different types of route leaks. So a customer receives routes from one ISP and leaks them to another ISP, multi-homed customer. The two culprits in this case are the customer who leaks a route and the ISP2, which doesn't detect or stop the leak. So we need both intra-AS and inter-AS solutions. Alexander talked about the role and the intra-AS solution. This next slide puts all the different building blocks together for an overall solution. I mean, not all of them. You will see there is one more slide similar to this one, which adds one more element. But the elements that we are looking at here are initially the peers, the two ASs have to communicate with each other out of band to exchange information regarding peering relationship in particular, ASN, interface IP, and a bunch of things. Following that, the configuration takes place regarding the peering relationship. And after that, the left side block, intra-AS route leak, that basically says from the ingress to the egress, either a community is sent or an attribute is sent to indicate that this route came from a provider or a peer, and subsequently at the egress, it should not be sent to a provider or a peer. So as simple as that. That's the community or the attribute that you could use there. Most ISPs currently use community. On the right side, the inter-AS route leak detection mitigation involves an optional transitive attribute, which contains a number of RLP or route leak prevention fields. These fields are the ones which do the indication between ASs that the route was received from a provider or a peer, and subsequently it should not be passed on to another provider or peer. That's the idea of the route leak prevention fields. And on the top we have secure RLP fields with BGP-SEC, which means that these RLP fields in regular BGP can be mapped into BGP-SEC flag bits, and then they are secured so that no tampering can happen with the RLP bits. This shows the configuration flow process. You start off with the out-of-band communication, which results in either customer role, provider role, lateral peer role, or a complex role. If it's a complex role, the out-of-band communication also is used to determine the sets of prefixes for which the roles are different. So once that is done, the configuration can follow. The RLP attribute, this is an optional transitive attribute. This includes, this is between ASs. On each hop, we add two fields to this, the ASN and the RLP. So each AS that participates adds its own ASN and also the RLP fields. The ASs that don't participate, they don't put this field in it, but this is a transitive, so it moves on from AS to AS. So this shows the benefit of that approach, the inter-AS solution using the route leak prevention bits. If you look at the prefix P on the left, which originates in a different customer cone, goes through AS5 to AS15 to the top of the customer cone, goes down, goes to appear AS1, and then it goes into the customer cone of AS1, and then it leaks. AS9 leaks it, and so what we have here is the blue ones in the middle, AS1 through AS5, are major ISPs which are participating in RLP. And they essentially form a ring of security. So any leak that happens in one of their customer cones, they will be able to detect it and block it from propagating into the customer cone of their neighbor's AS, or neighbor's customer cone. So in this case, what's happening is that AS1's customer cone, there is AS9, which leaks it, and then it enters into AS2's customer cone. AS9 happens to be in both customer cones. AS8 is also not implementing RLP. It leaks it to AS2, but AS2 is able to catch the leak and stop it there. So this works in partial deployment. A whole lot of ASs, customer ASs, various ASs in the customer cone may not be doing this technique, this technology. They are not upgraded, but yet if the major ISPs implement it, they form a nice ring of security, and we'll be able to do away with much of the route leaks that we see today. At least we'll be able to limit the propagation of those route leaks very effectively. So this adds what Alexander talked about, BGP open, BGP role capability negotiations, and that reconfirms the role in the OOB communication. And finally, once that is there, the process flow diagram changes a bit. So when you have the BGP role capability negotiations, essentially you'll be able to either confirm the configuration, in which case, so that confirms it, and that's good. And the other two possibilities are there may be a mismatch between the roles declared by the two sides, or the neighbor does not send. So those cases need to be thought through a little bit carefully and provide various actions that need to be performed, or or if you would use your own knowledge of the pairing relationship to set the RLP bits. So those can be specified more clearly in the document. So finally, these were some thoughts to share with the other authors and the chairs. We need not go through this. We did have a discussion with the chairs and between the authors. So I'll be happy to take any questions. So if I may ask one quick question to people who do intra-AS route leak prevention. So if you are currently using community and then if the specification changes, requires attribute, is that an easy switch over, or there are some complexities involved?
Job Snijders, NTT. I've argued before that a community would have my preference because it means that my deployment cycle will not depend on the software upgrade cycle. But Randy Bush pointed out, perhaps correctly, that with a community, we depend slightly more on how people type things into their routers. But we've seen with things like no export or no advertise that software implementers can deal with communities as if they were new path attributes. So I'm curious to know what others think about this, but an attribute comes at a deployment cost.
Thank you. Rudy.
Rüdiger Volk, Deutsche Telekom. Job, let me answer your question from my point of view. In my setup, throwing in another community kind of works more smoothly. On the other hand, I think that many parties do not have configuration systems that will be easily extended for doing this and rely on manual configuration of policy. And there, I guess, a separate attribute comes in as something that is kind of more secure and less easily messed up. So for the benefit of parties that are easier to mess up on the configuration, I guess an attribute actually is the better way to deal with it.
Randy Bush, IJDRL. Job, I'm a little confused. You're worried about the attribute because it will require deployment of code, which we all love. But yet, you want the vendor to enforce the community, which will require new code, which we all love to deploy. Mach nicht. They're the same.
They're not mutually exclusive, and they move at different timelines. So.
I'm not sure I understood. I want, the whole goal here was for the router to enforce valley-free peer flat. Okay? For the router code to enforce, it's going to take a code change, whether it's marked with community or with attribute.
The valley free is between ASs, and this what we are talking about is intra-AS. Right?
That is not what I'm talking about. I don't care about intra-ASs because if I can enforce it at the source, I don't need this whole external mess.
No, that is intra-AS. Doing it within the autonomous system between ingress to egress. That is what we are calling intra-AS.
Job, am I right? Do we need to talk offline? Deal. I could use another coffee, as you can clearly tell.
Jacob Hunt, Cisco. To enforce communities doesn't require change in the router code. It can be done in route policy.
Thank you very much.
Here to give you an update on MSD draft. So the motivation, the MSD, which is the maximum number of seats not is capable of imposing, varies widely from 2 on recent Linux up to 15 on high-end routing platforms. Looking at the aggregation when software and hardware are coming from different vendors, it's a wide jungle, so ability to signal what node is capable of is critical. So the intention is to let centralized controller or PC know what node is capable of. So in worst case, controller could just say, sorry, no service. In best case, could apply some additional logic. There's various algorithms to compress seats that there's ability to expand it by using binding seats. So there are also PSAP extensions to signal MSD in open metric objects. However, not every ingress node is PSAP speaker. PSAP only capable of signaling, not MSD. So if you're looking at a system with different line cards, you won't be able to choose right one. MSD values and signaling I'll describe in OSPF and ISS drafts. Both are working group documents. If you look at latest version, we have updated it to include also type field. So rather than just signaling, this is number of seats not can impose. Now we can also define what type. So it could be labels or seeds you recirculate. Could be all kinds of different types possible in the system. So the distribution through BGP-LS is straightforward, not MSD signals through new node attribute TLV. Link is signaled through link attribute TLV. And for subtype or type we define in AGPs, we use subtype, and the value defined today is base MSD uses most basic piece of metadata to compute proper seed stack. So AGP drafts are working documents. Thanks, Stefan, to organizing discussion about the role of MSD versus RLD. It's all clarified, and I believe everybody understands who does what. So we would like to ask for working adoption. Questions?
Yeah, if there's no questions or comments, we'll of course take the working group adoption request to the list. Yeah, that's it. Thank you.
Thank you.
Wait a minute. Oh. I may have these in the wrong order. It's probably easier to bring up the speakers in. Sorry.
Good morning. I'm a small guy. Good morning, Tony P. So that's just a selective route refresh. I think we call it the route refresh extended options. The update is relatively simple. What I had to do was basically change the whole sequence number arithmetic, which was relying on what was it, 1982, which is kind of obsolete and it wasn't described very well. So actually, I did the whole math. The appending is quite interesting to people who have to deal with sequence number overall, which I saw at least two proposals. This IETF again. So the idea is that you are shooting off some requests to refresh, and you're getting the X that it's starting, but the request is still under processing, right? While you can already request future refreshes for which you don't get the begin of refresh yet. So if you do that wide enough, at a certain point in time, you don't know whether the messages got misordered and one of the peers misbehaving. So what you have to do is basically have a sequence number, arithmetic, and rules that you cannot fall out of sequence, so you can compare those numbers. Thank you.
Hi, Tony. This looks really cute, but why don't we just use 4 bytes? Be done with it.
We use 12 bits, and yes, we can apply the rule. It will never happen, and then be here back in a couple of years, as we were many times before.
Make it 4 bytes, and it's what? It's 0 to 4 billion.
Okay. Yes, possible solution. The way the draft is working, and I saw 2 other drafts. We know that the problem exists, no? Been there before. 1982 has been written. It's not written cleanly. All right, OSPF is probably the only technology that really well dealt with the whole problem. So yes, we can blow this thing to 4 bytes and declare that the stuff never happens. And if someone starts to generate refreshes real fast, every couple of years you just tear down the session. That's one of the solutions. Sure. Having said that, if you work with a limited number of bits, I put an appendix which basically shows the clean 2-bit complement, which I will not go through. Okay, so it's extensive example, shows how the spaces rotate, and it has rules in the draft what you can issue outstanding, right, when you want to span a certain range. Request IDs are monotonic, so that's still the same thing. Yes, I basically will not go through the rules. The simplest thing to explain is that if you put out there a 1 and this is in processing, and you request a 2 and you want to request 3, you're still okay. But if you try to request a 4, they will become incomparable. So you don't know whether the 4 is actually you rolled over or not. Okay. The moment the 1 finished, you 1 lower, which means you can issue a 4 because it's comparable. That's pretty much it. I mean, there's no magic, but it's actually people have a hard time to grasp the stuff cleanly and do a lot of there's a lot of problematic implementation for this kind of rollovers. That's about it. More question or suggestion that can never happen?
Do you have Bruno's slides? I'll pass you the cable. You can keep taking questions if there's any questions.
No, I think the topic expired itself.
Okay. Thanks, Vinny.
Thanks so much.
And then we skipped Bruno and we're gonna have him come up now. We are gonna get Bruno's slides up now because I didn't have them in the right order. Do you want to try to take the thing? And we'll just flip slides for you because we're switching to Sue's laptop.
I can get.
I'm Bruno from Orange.
Oh, sorry.
I'm going to give an update on BGP next stop dependent capability. It's a short draft, but it covers two points. The first one is signaling of the capabilities to support MPLS entropy level. And the second point is to generalize the solution. I'll start with a one-slide summary of entropy level. It's a solution to improve the load balancing in MPLS network. It's also applicable to segment routing MPLS network. And it has been defined in the MPLS working group in RFC 6719. The solution requires that the egress first signal the capability to support to receive entropy level. So the RFC has defined signaling for LTP, RZPT, and BGP. And for BGP, it has used a new specific transitive attribute. So far so good, but then RFC 7447 has deprecated that attribute because the use of a non-transitive capability was not good enough. No, sorry. The use of a transitive capability was not good enough to signal entropy level. So we need to redefine it. And that is the first goal of that document, to allow BGP to signal the capability to receive entropy level for the set of prefix advertised in BGP. So it's in short, it's just a copy paste from the existing RFC, the entropy level RFC. So first goal. Second goal is to make it a bit generic, because at no cost we can add a TLV inside the attribute, which would allow different features to use different type value. So this provides a generic tool for BGP to advertise next stop dependent capability. So the first interest is that we save BGP code point, but the more interesting interest is that it will help deployment of future features. Why? Because we need non-transitive attribute for that signaling. But the issue with non-transitive attribute is that if one node in the network do not support it, you lose the attribute. So it's not very easy to deploy incrementally. So if you make it generic, new features will be able to reuse the same BGP attribute. They will benefit from pre-existing implementation and pre-existing deployment. Hence, for the new feature, it will behave as if it were not non-transitive. So for the encoding, nothing very specific, nothing difficult. It's just a new optional non-transitive attribute, which is used as a generic tool to advertise capability which are next stop dependent. So what we want to achieve is that if the next stop is changed, we need to remove that attribute. So that is the operation of the attribute. So while the next stop is not changed, we propagate the attribute. If the next stop is changed, the attribute is removed. And as per regular BGP capability, since it is a non-transitive attribute, if it's unknown, it is removed. The attribute is just a TLV. It is brought from the open session capability. By the way, since recent discussion in IDR, it might be a good idea to make the capability code using 2 octets on the length, and so it would allow a larger first come, first served pool of capability tree. For the entropy level capability, it's even easier. So this is the first usage, so we use capability code 1. Length 0, there's no value. So if you advertise that capability, it means that you support entropy level, and you are ready to receive entropy level in the data plane. Everything specific about entropy level is copy-paste from IETF98-IDR-20170331-0900, which define entropy level. In terms of IETF, we would welcome a comment and feedback. We already presented the document twice in IDR and in MPLS working group, because a part of the document is MPLS specific and another part is IDR specific. My understanding is that it should be better in IDR because it defines a generic capability for IDR. And so we would like to request for IDR working group. Any questions?
Once again, just curious how many people have read the draft? Good. Yeah, so we'll soon be discussing that working group adoption request on the list. Thank you.
So I'm going to be giving an update of all the IDR segment routing drafts. I know for the past 5 to 10 IETFs you've seen Stefano Providi do this, but I'm doing it in his absence.
Okay, the clicker working. Just give me a second. Okay, sorry. Should be good now.
This draft is the segment routing BGP-LS encodings for the IGPs. One case, since we're advertising global SIDs in BGP, is to add that to this as well. And in other words, we're going to accommodate the next draft, prefix SID, with BGP-LS encodings. This draft is in working group last call. There's been a routing directorate review and an update based on Chris's comments. Bruno had some comments. I believe there's a discussion going on, but I think Stefano has a resolution for all those, so he'll be updating that draft again in the next week or 2 weeks.
Okay, so we'll probably keep the working group last call open until we see the last document.
Oh, yeah, definitely. That's good. Yeah. And even you may want to extend it based on, the resolution of comments.
Yes, that is correct.
Okay. Mm-hmm. Let me just say one thing about the implementation report. There's a number of implementations of the MPLS data plane, but none of the V6 data plane for this draft. This document, there's a number of implementations of this document. It's the working group last call is in progress and implementation status. What this is the BGP-LS encodings for egress peer engineering. And you can see the additional BGP-LS code points. One thing that's changed is this BGP-LS protocol used to be BGP EPE. One thing we did, actually, this is my comment, so I'll talk about it. We changed it from just BGP EPE to just BGP, so we could use it for other BGP LS encodings pertaining to BGP. And this one.
So just a minute, on the draft IETF IDR BGP LS segment routing EPE, have you completed all of your updates to that one?
Yes, I believe so.
Okay, so I'll probably do a.
I do not know if Stefano has answered every comment during working group last call. I believe there's still some reviews left on it, right?
Yes, there are. So
Yes,
again,
yes.
see first comment. I'd like to close that one off too.
Okay, great. This one is the one that's not a working group document. This is a rather extensive piece of functionality that's been implemented. One thing here, I know if you were in Spring, you saw that the use cases for SRTE policy have been split off into a separate document with a large number of authors. There's an implementation status, but it still needs, the implementation status needs to be updated. It doesn't have the details yet. That's one thing that needs to be done. It asks for a number of new, there's a new SAFI, there's a new tunnel attribute type. That'd be nice to get that document progressed, the tunnel attributes. The one that there's a lot of documents based on that Rosen draft.
Right. I would love to progress that. I'm not. This is not exactly the time, but
Okay.
if you know of an implementation that will allow us to progress it, that would be very helpful.
Yes. Okay. Thanks. And then so we would like to ask for working group adoption for this so we can get the early allocations of all these code points. And I think we're going to be issuing a new version of this shortly.
And again, if you have any early on implementations of that, it would be good to update the webpage so we can put that in.
Yes, I'll take a step back. Finally, this one is the BGPLS encodings, both for RSVP-TE and for the previous draft, SRTE policy. This one is a working group document, even though the SRTE policy is not. This is a merged version. There were separate drafts for the RSVP-TE and for the SR policy. And this isn't. I don't think it's not ready for working group last call, but I don't believe because there aren't any implementations yet that I know of, at least. Whereas for this one, there is one, at least one. I think there's even more. That's it.
Any questions or comments before we move on? Okay, before we move on to our next presentation, I'm going to try to get my laptop to unshrink the slides. So everybody stand up, stretch, talk among yourselves, and this will just take a minute. Between switching laptops and switching back, it's like the laptop decided that all the slides should get smaller, which is
We can pop off behind if it doesn't work.
sure. Just take a second. Either this will work, or
We'll go to something
we'll
else.
go to something else.
I'm just keeping track of all the computer adoption processes that come.
Awesome. Thank you.
That I can send around.
Well, I understand.
That's awesome.
Oh,
Well,
not small.
they're still shrunk, sorry, but yeah, we're not going to take any more time messing around with the tech. So I apologize to the people in the back of the room.
Do you want to swap to the next one? Yeah, good.
If you're in the back of the room and the shrunk slides are a big problem for you, let us know and we'll switch to Sue's laptop, but otherwise we've got them all pre-staged on mine, so sorry. Yeah, exactly.
Okay, so Alexander Azimov, one more time. And now I'd like to talk about definition of ISP borders. You know, it sounds tautological that borders are very important of BGP border routing, border gateway protocol. And at the beginning, it was a simple stupid. Different ISNs, different ISPs. So, of course, it's obvious that border definition is used in multiple ways. It's used to permit or deny transmission of non-transit attributes. It's very important for hot potato routing and so on. But unfortunately, this definition is not does not fit anymore to their requirements. And first ad hoc was created with BGP confederations. In this case, there was a need to treat different members of confederation as sessions between different members of confederation as internal BGP sessions. But still, it was at micro level. But the need to unite network to make, for example, two networks operate as one also grew up at the macro level. And this, how I feel, was born IS migration draft, which describes step-by-step migration of for two autonomous systems to a single one. It's also provided a new ad hoc to support legacy autonomous system number between BGP peers. For example, if one part do not want to change its configuration. But still, what if we have a different situation? What if we have 1, 2, 3, not one, of course, several autonomous systems that want to operate, to have joint connectivity, to have benefit from it, but do want to operate their own autonomous system numbers. They do not want to migrate to a single one for some reason. And such situations are already happening. You can spend plenty of time and you will be able to make such a configuration. You can, for example, duplicate each non-transit attribute with a community. You can isolate routers to support hot potato routing. But I don't think it's a simple way. And do we need another ad hoc to, for example, show that these BGP peers are internal compared to other peers? So I do think that here we have another use case of roles. If both sides use this extension and both sides are internal and this state is negotiated, we can fit all these requirements in a simple way. So it's obvious how to support hot potato routing, because in this case, external routes should be used over internal. It's also obvious that IOTC that prevents leaking should be transmitted through such borders, because otherwise such united network would become a source of routing. And there should be also an option to enable the transmission of other non-transit attributes, but it should not be enabled by default to support partial deployment and avoid possible routing issues. So that's all. This the idea. Please comment.
John Scudder. Sorry, I had not yet read the draft. You did mention partial deployment just now, so that suggests to me that you've thought about it somewhat. I wonder if you would mind saying a few more words about, I mean, basically the first thing I thought about is, oh, do I have to have this thing fully deployed along the mutual border between these two different ASs that want to treat each other as internal, or does partial deployment work, and if so, how?
So for the first step, one part should switch their, both parts should switch their roles to internal. That's nearly all you need to support hot potato route. In this case, just the first point should be okay. The second point should be okay. The third point should be enabled when the networks are ready, so when the local preference values are synchronized. And for example, they're ready to also share meta attributes. But still, it's very simple. Just change of configuration only at the connections of these two systems. That's all you need to enable this kind of joint connectivity.
I guess what I was picturing is, imagine I've got, 10 different places where the two ASs touch, and I have the role extension deployed at 5 of those locations, and I have an older version of firmware at 5 of the other locations. How does that work, or do I have to, deploy it everywhere?
In this case, you will have not a problem, but these, for example, if you are trying to share your peering connections of these different networks, these traffic will go only through these links that are already supporting this extension. Still, other links will be still working, but there will be no transmission of attributes or something like this through these links.
Thanks. Other questions or comments?
Okay.
I, for one, intend to go home and read it because it's an interesting idea. Thanks.
Okay, thank you.
It would be good to read this and look at some of the leak stuff that route leak stuff we've already adopted, as this problem seems to continue to be there. One hope is that if someone has research time, you might continue to look at real BGP data, maybe the CADA new instruments or something else. If you know of academics, this might be helpful to research as well.
Okay, this is on using LLDP for peer discovery, BGP peer discovery. It started with Kay or Sean and myself having discussions, and then we brought Tiger in as an alternative to the LDP-like protocol he's going to, Hello protocol he's going to present later. So the requirements are, you want to be able to discover your peers without having to configure them. Now, what that allows you to do is you just run BGP on an interface, and then you will peer with everybody. You'll peer with somebody on that interface, and you can have most of your switch connections can be pretty similar with similar types of ports, depending on where it sits in the clause. You really only would need to configure the loopback. And you want to support peering on the loopback addresses too, and in case you have, I know it's very common to have L2 port channel or lag between switches, but if you have multiple layer 3 interfaces, it'd be nice to just peer on the loopbacks. And finally, and I know this will probably require some further discussion, we put this in sort of a late discovery of the authentication mechanisms and other things. We've added some extendability. Now, why would you want to use LLDP, link layer discovery protocol, or IEEE 802.1? Well, because you already have it on just about all switches and routers have already implemented this. It's a standard protocol, so it's vendor neutral, and there's already a organizationally specific TLV that's in 802.1ab. IANA has a OUI of their own, so you can use that organizationally unique TLV. So really all we need to do to use it for other types of discovery for IETF protocols is define an IANA registry for the types. And I think, there is a solution. I'm going to say right now, what a lot of people are doing, our implementations are doing, is they're using RA, and neighbor discovery and router advertisements to discover the link local, peering on the link local address, and then you can use that next hop for both IPv6 and IPv4 prefixes. Now the question is, for the working group. Are the flexibility of this mechanism enough to justify it over this existing mechanism? Okay, I've heard wild things you could do with LLDP, people claiming, but it really is a pretty simple unidirectional protocol. It's got 3 mandatory TLBs, and it has a TD time to live that defines the life in seconds of the information. So it's got to be refreshed periodically. The transmission, it isn't incremental. In other words, whatever you advertise in your LLDP PDU, it replaces all the previous. So you're really limited in the amount of information that you can send to what will fit in one layer 2 PDU. So we defined in this draft, we have two new that we added this registry for IETF specific TLBs in the IANA organizationally specific TLB. One is the interface address, and you can advertise multiples of these. It turns out there's a management address that's already in the specification, management port address, but since it's meant to be a layer 2 protocol, they never added an interface address. So that would be one thing, an IPv6 or v4 interface address. And then we added the BGP peering address, which isn't necessarily the interface address, and the local AS, and the peering address is much like all these past discovery mechanisms. You can peer on different addresses for different AFI-SAFI tuples, and all zeros is a wildcard. And a capability sub-TLB. This I think may need some more work because right now it's a bit flag. Now how it works? For establishing BGP sessions, it's really a discovery mechanism. It isn't a keep alive mechanism. So it's not. So let's say that the peering address goes away. We're not going to tear down the BGP sessions. Conversely, one thing we have in here is we have an option that because you want to make it completely if you want to peer in the loopback address and you want to make it self-configuring, we'll add route. We have an option to add. You could add routes to the loopback based on the interfaces on which you receive the LLDP peering address. So if you receive the same peering address on multiple interfaces, you could add ECMP routes for one session. Now, in this case, we do, since that's the only mechanism for adding the route, we do have to change, the routes do have to change when the peering address or the interface address goes away. We also have a flag that says to use GTSM for the TTL hack, as it's also known as, and we'd use a TTL for 1 or 2 hop, depending on whether it's a session to the loopback or a session to directly connected. And then there's some flags for authentication, but there's no keys or anything like that. One thing, if we keep these, it might be good to have some kind of security association. Because of course we're not going to put the keys in the LLDP. Tony, were you going to say something?
No, I'll wait until you finish.
Okay. And so I think this isn't in any stage except gauging interest and usefulness.
Couple points. I hope I don't forget any. Generally cool. I think this is super useful in terms of this thing can figure out what is the proper transport to run BGP over. That is much wider application, I explained. So first, the whole that I saw was that the interaction between this LLDP and BGP configuration, the session being up, is shaky. You say you don't hear it out of session. There are more cases like, okay, the info expires. Will you then tear down the session? Is LLDP kind of, I think that needs thinking through in a sense deeper. I think there are solutions, right? But there will be some interaction with the BGP FSM. Can be figured out. What I see this thing as being capable of is to, over time, more sophisticated things. Like, for example, we have the BGP message size problem, right? This could describe whether the open is new size or whether it's still the old size. And you could have the same BGP actually doing the proper thing, seeing the LDP, right? So this is basically a BGP transport description mechanism. And one day after we retired and sit over our herbal tea, we may find that we in BGP of TCP, and this thing will be indicated what transport it runs on. It could run on. Okay, so overall, I think not only the application of data center, I think this has very long legs. And I encourage thinking very, very carefully whether this is a hello and we do away with keep alives. I mean, there's all kind of wild possibilities, but the interaction with the FSM, whether it's bring the session down, when it shows up with preference, merits careful thinking, because I think this will have a very, very long legs while we're tweaking the transport. Thanks.
Jeff, I have several comments, including follow-up to the OSPF one from yesterday. So the neighbor discovery hack is probably not a good idea, just simply because neighbor discovery is partially about getting the interface up to a useful point where TCP could even work. So I know people do these sorts of things, but it causes some race conditions in terms of when you could actually try to get TCP up. I do like LODP. I do like the OSPF mechanism. And I think these are both useful things to say, hi, there's a BGP speaker on your network. The thing that I think is problematic between all the different proposals along these, whether it's LODP or the OSPF version, is it's a sort of wild card. Here's a BGP speaker. You've added in the text about doing the security stuff. That was a necessary missing thing for the OSPF one that you mentioned. The better one is, should I even peer with this thing? So it's not possible to really tell what the role of this is, especially in the OSPF case where it's multiple hops away. With the LODP one, it's a little bit clearer. What's sort of missing is something that, it's not a security association, it's sort of like a community tag or group ID, something that says, this is the role of the device, where it fits in the topology. Because the problem we're going to run into for all these different discovery mechanisms, either local or multiple hops away, is should I actually peer with this for, for example, I want to discover is this is a route reflector and have it actually handle topology distribution, or should I actually treat this as a discovery mechanism for like BGP switching fabric, in which case I want to do something very, very different. So I think a lot of these things probably could fit into some idea of a group. There's also the idea that you have to figure out what to do about the incoming session. I said, each of these mechanisms is saying this is IP address I want you to peer with. There's no indication about what address it was willing to accept. Right now, this would be implementable using these standard allow mechanisms that's sort of BGP wildcarding, and those tend to bypass a lot of people's security mechanisms. So some more clarification about that would be good.
Yeah, I almost think those are somewhat conflicting, the discovery versus, auto config versus security. The checking. The AS is advertised. Now, if that's
backbited enough.
Yeah. That's some validation.
Yeah, are you talking to a route reflector or an IBGP speaker?
Right. Oh, you're the role. Right.
Nicholas Feliz. So my personal dislike of this approach is the fact that I could have cases where LLDP is not running. I cannot even control the device that I have to configure LLDP on. And if I can think of the cases of BGP peers and automatic provisioning of services and BGP peering, this is something that I cannot use. So I would like to see
a hello mechanism in BGP rather than relying on an LDP to do this.
That's it. Somebody else is going to propose that.
I know. It's just
Okay.
that I know it's coming
Yes.
later, but I just don't want to see two different mechanisms
Right,
to
right.
do the
No, I
same
wouldn't think
thing
you would do the
because
same.
this, if you think of PECs and how the service providers may actually provision peering relationships, this could be a useful tool for them, but they don't control the peering device, so they may not even be able to dictate that the LLDP should be run on this. So
I agree. You wouldn't do BGP allows and this. You do one or the other.
Okay, Robert. So imagine we are at the IX, Internet Exchange, or we would like to automatically peer to the route reflector, which is the x86 host. The host is connected to the switch. So I have no LLDP relation to the BGP speaker because switch is L2 device. So I cannot discover something which is connected to the switch from any of the clients. So this works perfectly if you have data center, switch to switch, switch runs BGP. But if at any moment when I'm running BGP on a compute node beyond the switch, I cannot discover this and establish, let's say, IBGP session to route reflector because I have no LLDP relation.
So yeah, you can't do it across. You have to be on the same layer 2 network. Yeah, right.
Anchor Chen from Cisco. So I have two comments. The first one, I think, is just echo this gentleman said. Basically, I prefer a BGP-based solution for hellos. If we model after this LDP, right? LDP basically there's a UDP discovery, then followed by TCP connection. I mean here, UDP port 179 certainly is available, so we can do that. Then we do need to basically pollute another protocol, right? It's more generic, it's self-contained inside BGP. That's first comment. So the second comment is this. I noticed that here, basically some of the sort of ECMP related stuff is spelled out. BGP is very rich in policies. So in order to achieve best sort of minimum config or zero config, actually, there are a bunch of policies that's possible across, especially across the eBGP boundaries. So I think we need, so I like to see a clear definition, say, okay, what is it, what are we trying to achieve here? Is that for basically for minimum configuration, or it's just for neighbor discovery, or we trying to cover the wide range of policies, right? It's scope, the scope, right? Because if you're trying to say, okay, we want to achieve zero config, sort of thing, right? BGP, I mean, it certainly gets very, very large. The variety of features, across eBGP boundaries.
I think rather than the volume of configuration, this is a step toward having more. You're still going to need configuration. You're still going to need some minimal like the allow all policy,
right?
For a minimal data center fabric that you want to just come up without much.
Certainly.
But it allows less differences between.
Yeah, I think this kind of
satisfies that. It's not. I mean, granted, you're not going to eliminate every.
Yeah, I think I agree.
With just this, I mean, you could eliminate a lot though.
This type of mechanism seem to work very well in sort of a very homogeneous environment, right? You can sort of have a global config instead of a neighbor config.
Yes.
The LLDP is quite limited in the way data is found and conveyed. All the TLV have to be within the same 802 frame, right? So perhaps it would make sense to reach out to them and talk about extension. I mean, this stuff's been going on for the last 15 years.
I think if we decided that the existing thing was limited enough, rather than trying to coordinate it, we would be better to take the BGP hello mechanism where you do something like stun and LDP, because this standard has existed for such a long time, and in 802.1, I mean AV,
it is very limited. Again, you're limited to
Yes,
size of
yes,
802
yes, you
frame.
are. Yes, you are.
This is a caution based on Tony's comment, or if you're going to try to add something to the BGP state machine, please be careful. There are a lot of options that may not be in the text in sections, but if you look at the state machine, there are a lot of options. If you were going to glue things together, you have to be careful to either use, because in the past, things like this were used in a different manner, and you might be able to just set one of the optional pieces of the state machine. So just be careful if you're going to go that direction to dig into the state machine and understand. And I'll be glad to help you. Those of us who lived through the 4271 state machine hack might be able to give you some aid.
Okay, thank you. At this moment, I think it should be advisory, but as opposed to modifying the state machine, just because, it's a later
I think
violation.
I agree.
Yeah.
I agree.
Hi, Nick Teague. I just wanted to comment really. I mean, this is stuff I'm already doing with scripts and stuff like that. So if you can abstract that away from me, we were having to do it with scripts and it's already there, then I can move my scripts back a couple of layers and I don't have to kind of integrate with a whole load of different stuff. So I generally think it's a good idea to do. Thanks.
Thanks.
Cold in the room. I can understand how many.
Hi, everyone.
Hey, just real quick, this is Wes. I missed a comment in the Jabber room because the window didn't tell me that there was new comments in the Jabber room. This is related to the previous talk, so I'm apologizing. They're a little delayed, but Kiera wanted me to mention to Tony that ideally if LLDP packets are lost, you have a much bigger problem with regard to discovery. Having said that, we could augment the text to make it a bit more robust. He totally agrees about the comments about tweaking the transport, and to Jeff that a group ID makes sense. And then LDP-like discovery mechanism is a lot heavier. The biggest advantage of LLDP is that discovery is decoupled from the protocol, namely BGP.
Wes, would you mind also just pasting that comment into an email to the chairs?
Sure.
Just so that we don't have to retype it. Thanks.
Hi, everyone. My name is Gaurav Dara. I'm presenting for the authors also. I'm one of the authors, and we have some of the vendors and also the operators on the draft. So this is a BGP extension for SRv6 VPN. So one of the primary thing is some of the details of the draft are actually in these other documents, which we have. We have actually presented the programming NetBGM document, the network programming in the Spring Working Group. And also we have the prefix set which is going through the working group last week. So what's the problem? We want to enable the segment routing over IPv6 SRv6 data plane. We want to advertise the SIDs and the associated functions for it. And of course, the main use case is to reduce the overhead of migration in the brownfield deployments. So what's our solution? We are actually proposing a new BGP extension. It's actually an extension of BGP prefix SID attribute with the new SRv6 VPN TLV. And this is how the TLV looks like. So we have the type field. It will be code assigned by ANA, and the length and reserve field. And then we have the SR SID information is actually encoded in the TLV in the bottom. And that looks like this. So you have the SID type, which would be extended to multiple other types in the future. But today it will be associated with a VPN ID. And that VPN ID is actually encoded in the SID, SRv6 SID. And the various VPN IDs and associated functions are actually encoded in the end function types, which are the details of that is actually described in the in the network PGM document. So NDX means it's an end function with the cross connect, and DT is the end function with the table lookup. Similarly for the V6. So we have the NDX means the end functions with a cross connect to an interface in a V6 VRF, and then NDT means the end functions with a table lookup for that particular prefix in the V6 VRF. As I said, in the future, this will be extended for the other end functions as well. One key point is that we are not saying that these are the only end functions which can be encoded. End function, according to the NetPGM document, is the function of the egress PE. So any kind of end functions be associated, and it is a local function, so it has local value. So once it reaches the egress PE or the traffic, only the egress PE knows what to do with that function. And more details are actually in the NetPGM document and also in the fixed document. Next step, we are seeking input, and this is early, seeking any feedback, any comments or suggestions from the working group. Any questions?
Jorge Rabadan, Nokia. So I think this should be discussed also in the BESS working group. It's all about the VPNs, right?
Yeah.
So secondly, I assume you plan to use the same TLV for eVPN routes as well?
That's right.
So far in IPVPN and eVPN, we have either 20 or 24-bit VPN identifiers. So I wonder why that is not enough. In other words, have you guys thought of restricting the sets to 24 bits so that we can reuse the VPN identifiers that we already have in the NLRIs?
Yes, so we can use a similar. However, what we thought about is the as I described, the end function is just the function of the end node. So we are not dictating that how many bits can be used. It is all flexible. So you can use the 24 bits or 20 bits.
But if you use that, you don't need the TLV anymore, right?
However, in the brownfield deployments, if the ingress P is actually MPLS only capable, right, and your egress P is actually capable of both SRv6 and MPLS, we don't want to force the ingress P to be upgraded in order for the solution to complete. You can have a hybrid topology.
But even in a hybrid scenario, if you use 24-bit sets, I don't see why you would need the TLV. You know?
You mean 24-bit set?
Yes, because then you can encode that in the existing MPLS fields, right? You have 3 bytes for that. As an example, in eVPN, we even support non-MPLS tunnels. You can encode 24-bit VNI identifiers in the MPLS field, and that's pretty much good enough, right? You don't need extra additional information in BGP. That's my point.
I'm Patrice from Cisco. I think I suggest Jorge to read the net programming guide. It explained very well why we are doing this. Actually. The first slide that we presented. Go ahead. Okay, so let's think up after. Okay, thanks.
I'm sorry, did the last 2 people give your names just to help the scribe? If you could do that, just take a moment and...
Sorry, Patrice Brisset from Cisco.
Okay, and the gentleman before him? Good, thank you. I missed it.
Jorge Rabadan, Nokia.
Thank you so much, Jorge.
Any other questions?
From Cameron Raza, please take a look at the SRv6 net PGM document.
Yeah, that has all the details.
So one comment from me as chair, you haven't asked for working group adoption yet, but you do have, the IDR string in there in your file name that suggests that you might be asking for adoption at some point in the future. Before you ask for adoption, please cut your ridiculously long author list down to 5 or fewer.
Okay. Tony again. So I'm showing a work with fell out from a lot of practical consideration, and it's basically a suggestion to introduce uptake compression type of filtering on BGP. Yes. So what's the problem? Why? Right? So BGP is moving towards being LIDDB. Okay. We are, for practical purposes, we're running a large distributed database, especially for the overlay state. And it's coming along very nicely, but what we start to see is the necessity for transaction, hence the route refreshes that we want to do in parallel, because we start to do more and more things where we just drop updates and we may need them later, right? So we want to refreshes. And we start to generate pretty spectacular amounts of volume, where I see certain deployments, right? And we just somehow, I don't remember we ever deprecated anything or cut anything out, right? So EVPN is doing spectacular amount of volumes. We have XPath, quite spectacular stuff. The NAV stuff is coming in, the V6 is not particularly known for its very, small size of things. And where we're pushing BGP also are in environments which are somewhat IO constrained. And IO constraint does not necessarily mean that, that the link, we're running them with like 19 kilovolts links, but we're running the stuff more and more hops away, right? Rod reflectors, multi-hop BGPs, and we're running them through a lot of virtualized IO, which is costly, right? Yes, there are solutions and all kind of stuff is being pushed, but we are virtualizing lots of that stuff, and we're virtualizing sometimes for very small purposes, but they end up pushing very large amounts of volumes. So yeah, how do we approach the stuff? Sure, you can run through a compressing tunnel, right? That causes all kind of problems. Starting from the fact that lots of this stuff has to do with security, you end up with key management, and lots of this stuff has to be implemented, and you are pushing the BGP session off the forwarding path. Just its own set of challenges, right? So you have to muck around with next stops. Can be done, sure. BGP is the Swiss Army knife, it doesn't even have a handle, it's all knives. Yes, wonderful, right? Got to love it, got to love it. So really, and what is also happening is that we are getting tons of CPU compared to what you had on traditional routing platforms, right? CPU cores are becoming cheap, plentiful, very easy to grab, very easy to provision. Very, very fast cores, not so much, right? So what if we start to grab this idle CPU stuff lying around, or it can get cheaply, to actually push the IO envelope? And here, so it's on embedded system, the channel filter architecture pattern is extremely helpful, right? We can start to stack now filters on the channel we're running on this TCP session. And that's one of the first suggestions possibly, but that's a suggestion actually that we see a lot of value in. And that's basically, let's go and compress the BGP traffic. So further observations, like it sounds like, yeah, okay, what can you get out of it? We are really chatty, right? BGP encoding is fat. We like send small things, and we like to send a lot of repetitive things, right? So the sync markers being point in case. We repeat these attributes endlessly. We repeat this next stop endlessly. That, of course, can be saved by changing the BGP encoding, right? We can start to carry attributes as a separate information element. So we basically start to break up the tables in terms of databases. We can start to carry multiple tables and keep those tables coherent and build indices and so on. It may go there. It ain't gonna happen fast. We all know that, right? But running a filter on a channel is a very cheap proposition if you think of terms of how do you push forward deployment. And I will talk a little bit more like asymmetry of the whole thing and what we can play to. So the IO bottleneck, again, when you start to look at the practical deployment, it is always the weakest things that hammers you. And you may have a very fat link, but you may have a TCP stack that is struggling with a lot of small stuff. Or you may have a TCP stack where a lot of things are already competing for TCP session. It is always the weakest link that is actually, ultimately you are running a control protocol over a user transport, right? That in itself is a very significant problem. So you're competing with user transport, often you compete on virtualization. If you have a full chain, fully debugged to prioritize the BGP traffic as we had with high-end platforms, you know, we always made this thing work. We control the transport less and less. We don't know where it's going, who's carrying it through, how many stacks it has to poke through. All right. Another observation is that compression is asymmetric, right? So I don't know how many people know that. Actually, compression is, just like security, a very asymmetric filter. So it preconditions actually far less CPU than you think on the compressing side. It is extremely cheap on the decompressing side. Very easy and extremely cheap CPU-wise, shockingly cheap actually. Again, it's a classical channel filter, so you can stack them. We can start to build security filter, compression filter. Maybe we start to build translation filters, where you take one type of BGP encoding and make it something else, and translate again in traditional BGP on the other side. It's an incredibly powerful architecture. It's like the Unix filtering, where you do these things that you stick on top of each other. All right, so what plays for us, Huffman encoding is extremely well understood. It was complete black magic in the 80s. It's fantastically well understood today. I mean, implementation are extremely portable, very easily accessible. Someone, you know, Alder and Huffman were gracious enough to give us this incredible piece of technology for free that we take for granted. There are people in the room who remember that it was considered absolute black magic when it was happening. We can stack it. What's nice about running a filter is completely agnostic what you carry over it. So this whole thing is AF agnostic. We change encoding tomorrow, we add new AFs, we do whatever we consider necessary doing on the BGP encoding. This thing would not break, right? Again, there are technologies where you can go lower in the stack and say, well, the interface should compress. We should be agnostic to it. But BGP is a control protocol. We want to be in line. When we get pushed off, out of the data path, we start to cause problems. Again, which we handle. I mean, route servers, IKZ path, we do these things, but it just makes things complicated. So what's the suggestion? As usual, we need a capability, right? So we can show a capability that we can decompress. And that's actually good enough. The compression, decompression are orthogonal, right? So we just need to know that the peer can decompress. That's good enough. I'm not pushing it to asymmetric negotiation because traditionally we do this like both guys can do that, we're cool. But you only advertise that you decompress, right? So I can compress towards you. Whether you compress towards me is entirely optional. So the whole implementation of a thing like that is orthogonal. Which set you support? You just have to support decompression. What is interesting is that compression causes delay. And for certain deployment scenarios, that sucks, right? We have this BGP beast, and certain people want it to be a Ferrari, and certain people want it to be a four-wheel vehicle, right? That goes through all the terrains. And when you flip on a filter is always delayed, whatever you do, you know? VDOR sharpening, blah, 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 denoising, all causes delay. So when we have actually IO that is fast enough, and we're really smart,
we want this compressor to switch on and off. Or maybe we're really smart and we send real rubbish across BGP and the compression ratios are really low, because let's not forget it's Huffman, it's adaptive and adaptive compression. So we have to have the capability to switch it on and off. How you do that is entirely implementation dependent, but the way you want to run this filter is to allow compression being switched on and off. So basically what we end up with is a mixture of compressed updates on uncompressed updates. And I show one picture what it looks like. And then the things that are really delay sensitive, like keep alives, we surely don't want to compress, right? We don't want to touch that stuff. Again, it is important to point out that it's asymmetric, so the decompression is extremely cheap. We're talking 200 lines of code, you're done. It can be done inline. It's CPU-wise, it's extremely lightweight, which means that we can run it easily on low-end platforms, which is also a consideration. So, one picture. If you have an uncompressed stream at the top, it's probably unreadable, but looks cool. So this color, which my wife would call mauve, right, is that 1, 2, 3, 4 are just usual update stream. Then we have this beautiful orangey thingy, which is a keep alive. Then we have A, B, whatever to J. Then we have a route refresh request, because we don't have that many message type. That's the cool thing, right? And then comes some more stuff. So what happens is if we get enough of something and we decide it's worth compressing and we see like our IO sucks, we just flip it on and we send something which is a compressed update which contains the 4 to 7. We get some more stuff and we just don't have enough volume. Maybe we run this 8, 9, 10 uncompressed, right? And then we start to realize we want to compress, but there's a keep alive in the middle. So we keep on waiting for more data while we push the keep alive out. Observe that we need to not violate any casual ordering. The keep alives that the route refresh requests have no casual ordering implications on any of the updates. If the most extreme implementation would be really, really smart and look for stuff that does not violate casual ordering of the updates and can be compressed better. But that's probably where your boss basically tells you that you really have a job to deliver something in time, right? Well, there's a research community. They always look for these kind of problems. So what happens is that the keep alive goes out, you got enough volume, you push it, and you keep on compressing. And now something interesting happens. We are bound by our 4K, right? Whatever we do can't be bigger than 4K. So we have to take that into account, because we may suck up possibly too much data. Well, we can be extremely conservative and say, we'll never blow up through the 4K. But we are running on adaptive compressor. They're not magic. If the pattern changes drastically, you may be too over-optimistic and blow through the 4K. So what I have in the spec is the possibility to send an overflow fragment. So you may end up with 5K compressed thing. That's okay, not a hard thing. You send the 4K and you have an overflow fragment of 1K. Once you blow through the 8K, you have a massive problems. But we are talking, lots of stuff that you didn't compress in a single thing, which is probably too much delay. So this proves actually quite practical. Same thing with the route refresh request, and we push more data out. Can you take it towards the end? All right, cool, Nikush, thanks. All right. More interesting things start to happen if we start to play with the stuff excessively. What you want is possibly having multiple compressors running at the same time. So the format allows you to run multiple compressors towards the decompressing peer. Not too many, but let's say something like 5 or 6 can make for very interesting implementations of the stuff. The sender is allowed to reset the compressor at any given point in time. So I can send a compressed message saying like, please reset your decompressor, forget all the dictionary, and decompress with a completely fresh decompressor. Has a lot of interesting applications again. On the compressed message, you indicate a couple of things. You want to give the decompressing side a hint. What is the buffer size? Don't forget, it's not 4K.
When he grabs the 4K, this thing decompressing may become 8. So you want to tell him, please get yourself an 8K buffer before you decompress. That's advisory because the decompressor library works just fine by giving you decompressed 4K and say, here's the rest of the bytes, please come again. I can decompress it for you into the buffer again. But it makes for far more efficient implementation if you have those buffers. If you have maybe an 8K buffer, 16K buffer, and so on. Depends how fast you want to go. Like I said, you have one overflow shot, which works out nicely. Just set the bit, okay, I immediately send you behind it and update with the overflow. And possibly reset number of compressors up to 8. And that's pretty much the whole sauce. So, now, the French gentleman in the back.
Randy Bush, IETF98-IDR. Thank you. I am totally convinced now that extended messages must apply to all types.
Nikos Triadafylis. So in my not so distant past during Cisco, we profiled BGP and throughout from input, best path, output. And BGP has absolutely no problem handling whatever you want to throw at it on input side. Most of the time, BGP spends when it comes to CPU or processing is on update generation, formatting, and replication. So having said that, 2 comments. One is that my concern is the overhead that this imposes during update generation or replication, because now you could have, from an implementation perspective, you could have different peers, some of them which could compress, some of them which could not, and effectively you're breaking them into different update groups where previously they were going to be in the same update group, and effectively making this more expensive during update generation, formatting, replication for BGP. And on the input side.
Okay, but I mean, is it now helpful to have an implementation discussion where my data point completely contradicts your data point, which is all based on how you structure the whole thing, in which environment you're running, and so on? That has nothing to do with the standard. You don't need that, don't run it. Millions of people don't run that path.
True. That's
and
okay.
That's about the discussion. If you write your BGP in Python, you probably don't want to do that.
Yeah.
No, which is entirely fine.
Right,
Look,
but coming back to the point of input, you indicated that you're trying to solve a problem where you're running BGP over what? Over constrained I/O?
yes, like I said, the weakest point in the chain is how much you can put out, right?
Okay.
So before anybody else says anything, I just want to point out that we're running on schedule right now. So let's cut the line after Garov and try to keep comments. You know, you don't have to like censor yourself, but just keep it to the point. Thank you.
Yes, and if we descend to data structures and so on, then our data points will widely vary, and if that's absolutely no use to you, just no implementer use it.
Right. I just don't believe that this is a problem BGP needs to solve.
Well, so your data points don't show you a problem. I have data points where the problem is extensive. Okay, and we can argue the whole day about it. Okay.
From Kier, Patel, and Jabber, we have an IDR draft for extended messages. If the messages are extended with bigger window size, how would the solution stack up considering convergence is paramount for BGP?
Well,
Please just send it through chairs.
yes, and my answer is, when will the extended messages be ready? And when will I have all the clients supporting that end? Yes, the world will be a better place when the light speeds up finally.
Robert Reszuk. So one of your data points and fundamental justification is I/O bottleneck. And that I/O bottleneck in the virtualized environments really applies when you have very badly designed system. Because when you are running BGP in your container or VM with a DPDK interface or SRIOV, PCI virtualization, the bandwidth, it's tens of gigs. If you are telling that BGP, it's not enough for BGP to have tens of gigs of bandwidth through the box by passing hypervisor, something is fundamentally wrong here.
Okay, so you don't have the data points, fine.
Jacob White, Cisco. I'd like to agree with Nikos. The convergence is affected mostly by root download, secondly by route policy execution, and a very, very far third by the what you're talking about, the data rate. Right?
Yes.
Now, so convergence can take some time. But I do remember a time I have a data point where I was on a customer call and they wanted, and I asked them to do clear BGP, soft, to send a route refresh, on a VPN session with millions of routes. So, no, we don't want to do that. No, we don't want to do that. Go and do, yes, no, do it. So they did it, right? And so, okay, let's go and have a look at the input queue, see how long it's taking. 0. Guys, it was already done. It was the root download. That's where it's the problem.
Yes, and
we're not solving any
yes,
problem. There's no
and
problem.
think through that we have deployments where the RIP download doesn't play any role at all, and we're sloshing tons of volumes. And it's actually something we do a lot.
Stefan Mikowski from Orange. First of all, I don't dig into the detail, so I'm not telling that it's bad or it is good. I just trying to understand what is happening here. What I see is that if I have some I/O issue, you are telling about that we have plenty of cores now, but the frequency of each core is decreasing each year. So if I have some issue with I/O, is the best solution maybe to try to load balance the I/O against multiple cores?
Yeah, but we don't have multiple TCP sessions. You always start
Why not? Why not?
Because we tried that 3 times over the last 20 years, and we can have this discussion again. It's like BGP extended messages. Yes, it's a much better solution. Go give it a shot. Has been how many times did the multiple TCP session die? 3 times? Okay.
Garuda, Cisco Systems. I'm curious, have you done any kind of analysis on proof of concept on this idea versus just doing a packing regularly, and how much was the impact?
When I present data like that, it's pretty high confidence that it's worth doing.
We should go on.
Thank you.
All right. Thanks a lot.
Just introduce yourself to.
This is Jie Dong. I'm presenting. I'm presenting this for Zhen Qiang, who got sick this week and go home early. Okay, basically this is a straightforward extension to the traffic action extended community for the flow stack, and only one new bit is defined. We will talk about the details later. And the motivation of the work is currently the operators need a solution to support dynamic and scalable fine granularity traffic steering to meet the requirements from the customers. And one of the solutions can be the traffic flow specification. And the flow specification distributed by the BGP flow stack is stored in a separate RIB according to the AFI-SAFI. And then this information will be installed to the dedicated hardware, usually shared with ACLs. And this kind of dedicated hardware is usually is expensive, and the space is quite limited compared to the space for the normal FIB. And according to the recent requirement, the number of the flow spec rules used for the traffic flow steering can be quite large. So this is a problem for the limited and expensive hardware resource. So to solve this problem, it is better to populate some of these flow spec rules to the normal FIB if it is possible. And one of such kind of flow spec rule is the destination prefix-based flow spec rules, and it can be installed in the normal FIB instead of the expensive limited hardware. Okay, we go back to this straightforward extension. Basically, it's just one bit in the traffic action extend community to indicate that the flow spec rule can be downloaded to the FIB if it is possible. But if the FIB this bit is set, but the associated flow spec rule cannot be downloaded to the FIB, this flow spec rule will be ignored. And this bit will need to be assigned by the INR. So this is just any comments?
Robert, so actually FlowSpec doesn't prohibit you to install it wherever you like. I don't see any need for any extension because you can put it to the FIB today if your FIB supports a match on various fields. You can put it to the IP tables on the compute nodes if compute nodes runs BGP. So I don't see particular need to do any other bit indicating put it there, put it here.
Okay, it's already supported.
Jeff, as Robert made part of my point, if it's something that can be done just through normal forwarding, you could do this. The thing that makes this a little bit problematic is FlowSpec has implicit ordering. You know, the 5575 disk stuff is adding explicit ordering as well. So there may be cases where you start off thinking that it's okay to install it to your FIB, depending on your system's implementation about where an ACL is versus where FIB is. But if you add in different rules that cause different ordering, then this may suddenly change. So I think that while this seems like a good idea to you, this may actually complicate your implementation.
Yeah, I agree. That's for the normal flow spec rules. There's an ordering requirement, but for this traffic steering requirement, there's no ordering for this different prefix-based flow spec rules. So they are basically they're similar to the normal routes in the FIB.
Right. The observation is if you're controlling your inputs that strongly, then the need for a bit is not really there.
Yes.
Rüdiger for Deutsche Telekom. It seems to me that the semantics of the F bit is, I don't care whether this rule actually is used. Would you think that's the correct interpretation of the semantics?
This F bit just give you action on this flow spec rule, but if it is applicable to be downloaded to the FIB, it's
Are you expecting that insertion of such rules will be really managed like I know the exact subset of routers that actually will act on this, and the other subset that will just ignore it? I have a big problem in seeing that's a really useful thing. I rather would think if you actually apply, you either know exactly that all of your devices can do it, or you are driving your network into a dangerous, undeterministic mode of operation.
Okay, maybe you need to know that rather than device already supported. Yeah, maybe.
Hello everyone, my name is Xiaohu. This talk about BGP neighbor of discovery. BGP has been widely used in some MSDC as IGP. However, it's not good as IGP from perspective automation. For instance, connection address and AS numbers need to be configured manually. In the case where loopback addresses rather than interface addresses are used to establish BGP sessions, either you need to configure state, role, or enable IGP. At least two of the top three public cloud providers in China have mentioned this pain with us. This job describes BGP peer or discovery mechanism by borrowing ideas from LDP rather than LLDP. The BGP routers could discover its physically connected peers through the exchange of the to be defined BGP hello messages. When BGP peers are discovered, the BGP session establishment process should be triggered. In the case where the connection address or loopback addresses, route toward the loopback addresses should be created automatically. The BGP hello message is a new BGP message which has same fixed size BGP handler as the existing BGP messages. However, the hello message must be sent as a UDP modcast. 179 is suggested port number for this UDP packet. In addition to the fixed size BGP handler, the hello message contains the following fields, such as version, hold time, message length, and TLVs field. In the TLVs field is number TLV, connection, address TLV, and other TLV to be contained. This is formatted ASN TLV. This is formatted connection address TLV. Any comments, sessions?
Jeff, so all of my prior comments about LODP also apply here. You need to understand what you want to peer, what the roles are of the things peering together. So I think both of these ideas are good ideas. And I think the thing that's sort of different is that we're getting different levels of scoping. You know, the IGP-based version requires a completely new protocol. The LODP takes an existing protocol that has link scope. This one probably is somewhere between link and subnet scope, because you are saying this is multicast capable. You're using the all routers one. There's nothing stopping you from using a different multicast scoping to actually flood this further within your network if you're running multicast, as an example. So
it's the link local multicast.
I see that is the one you're proposing. I'm suggesting that other multicast scopes may also be applicable.
Okay.
It goes together, Phyllis. Could you go back like 2 or 3 slides where you had the AS number? Oh, too far. Yes. How are you using the AS number? This is just to advertise the AS number of the peer of your own?
Yeah.
Right. So personally, I think that...
Not necessary, right?
Hmm?
You mean this is not necessary for the type?
No. I didn't say that. I was trying to understand what it is. And basically, in the TLV, I would like to see more additions to the TLVs to basically indicate the AS numbers that you're willing to peer with.
Yeah.
As well as VAFs for each AS number, possibly.
This TLV contains the advertising router's own AS number.
It contains its own AS number,
Yeah.
but it doesn't say who is he willing to peer with. So, for example, it says, okay, I have, this is my AS number, right?
Yeah.
And I'm sending to you.
Yeah.
That doesn't mean that if you receive this, I'm willing to peer with you.
Yeah.
Right.
Whether or not to accept a session from given AS, it's a local policy, I think.
But you will keep trying. The peer will keep trying. Everybody who sees this will keep trying to establish with you.
Okay.
Another jabber message from Kayer. I'm not sure if the hello mechanism is needed inside BGP with keep alives. There are discovery protocols. Let's leverage them and not load BGP up.
Okay.
So, Robert, as you know, perhaps we have exactly the same draft called BGP Auto Discovery proposed in 2014, except it went through a couple of iterations. But I like your transport. The UDP 179, it's something nice to have here. So my suggestion is if you can take a look at the other draft and perhaps take the information which has been massaged for many years to actually use for auto discovery and put it here, perhaps. It would make sense.
Okay, good.
Yeah, regarding the ES number. So it's 4 bytes. Let's just take it as 4 bytes and be done with it. Okay. 2 bytes just fits into 4 bytes.
Yeah.
So U short is part of U long. My suggestion, get rid of this TLV, just put it as the ES number in the as a part of the header. Instead, previous page. If you go back to the previous page, yeah, add his, yeah.
Put ES number here?
Yeah, it's 4 bytes.
Okay.
Hi, Rick Taylor. I like this in principle, and just to follow on from what Jeff was saying about, instead of using a link local multicast, we can use a wider multicast. How are you going to secure that? I'm not sure I want to broadcast over UDP my AS number and the AS numbers that I'm willing to peer with over what could drift across the internet. Security in multicast is tricky, as we all know. So before we get too excited about shouting across the internet, here I am. Let's just have a look at the security considerations. But in general, really like it.
Okay, thank you. I will consider the security.
So that's why original draft has link local only, and security consideration really would play an important part if we go beyond one hop. The intention of this presentation really is to provide easily to extend transport for auto discovery. So it's not limited by IEEE specification or anything else.
So there's a basic security mechanism for these types. Then, if you look at LDP, I think there's a IFC basically use the TTL hack. I think let's just spell out instead of doing another draft. Just put in, say, okay, TTL is 255, and it has to be, when you receive it, has to be more than 254. Okay, there are multiple drafts for multiple protocols. Basically, this is for discovery. That was the same thing.
Okay, thank you.
Jeff has his comments to the chairs. So we obviously have a lot of interest in doing discovery things since it's now popping up in 4 different scopes and 2 IGPs. This seems like something that all the authors should be swept up into one place and get the work done in one place rather than IDR and OSPF and ISIS and et cetera, et cetera.
Good suggestion. Thank you.
Thank you. Is this one question from the chair? Is this topic of auto discovery something that has timeliness? Should we hold an interim? How many people would like to hear an interim on this for BGP? Okay. Thank you. I think if the scribe will indicate, I will contact the authors and try to see if I can set up an interim date. Thank you.
We made it to the last one. Yeah, it's Jacob Heitz from Cisco. This draft is based on a true story. This was an actual bug we had, and Dongling spent a lot of time on this and wrote the draft. She's not here, so I'm presenting for her. I'm going to go here first. The problem is with the RT constraint RFC, It says if when advertising an RT membership and LRI to a non-client peer, if the best path is selected as the path selection procedure is a route received from a non-client peer, and if there is an alternative path from a client, the attributes of the client path are advertised to the peer. It doesn't say which client path, right? So it could be any of the client paths, and it's a random choice. Right? And that, if you don't choose the right one, it causes a route oscillation. Right? So the solution that we implemented that then fixed the problem was to for the route reflector to always prefer the client path when selecting a best path. This preference must be expressed before step F. It may be expressed at a higher layer. So now I can go back to the beginning and describe the actual loop. Okay, first thing happens is the bottom of the diagram there is. Do we have a pointer? Oh yeah. These two and one is the next distance to the next hop. So the RT is advertised from two PEs, PE1 and PE2. So we end up with two routes here. One from colon 6, IPv6 address, and colon 5, and the best path is this one with metric 1. So now the two best paths get sent to the higher up route reflector, and he has the same metric to the next hop. So the metric to the next hop is not considered. So we consider the peer address. The lower peer address gives you the best path. Okay. Next one, that gets sent back to RO3, and the originator gets sent to the router ID of the sender. So that becomes number 1. So the best path is, so this guy's best path is from a non-client. So now he needs to pick a client path to send back. And he's got two of them, that one and that one. Right? So he picks one of these at random, and in our case, he picked that one. Right? So it goes back up here, and it replaces the previous. It replaces this path here. And now that is the best path. So he sent, whoops. So he sends that back down, but this this route reflector drops it because he has the same cluster. He has a cluster loop. And we are back to the original state. That state. So that's a loop. Not a loop, a route oscillation.
Can I ask a clarifying question?
Yes.
Can you go back one slide, please? Wow. Sorry, forward. Forward. On that picture, you show that route there, you say originator is 1. Does that matter for this scenario? Because that's wrong. The originator shouldn't have gotten rewritten by that route reflector.
Yeah, this route reflector writes the origin as 1. It doesn't actually matter, but
Oh, if it doesn't matter, that's fine. It's a bug. He shouldn't rewrite it. Go on.
huh? No. No, he should. He actually does, right? That's one of the rules.
Okay.
He has to rewrite the origin to himself.
You know what, if
Pertaining to
it
the
doesn't
client.
matter for the scenario, keep going, but we can take it offline.
Jeff has it. Unfortunately, it's the whole reason why this presentation is even here, is that unfortunately 4684 does kinky things in terms of rewrite because you're forcing the route to come back down so that the VPN route flooding goes along that path. So this was the attempt to do that. And
Okay, it's coming back to me. Yeah, thank you. Sorry.
So I apologize for the drug-addled, this is how RTC was written, but this is what we have.
Thank you. Sorry for the interruption.
Are you done or?
Yeah, go ahead.
Okay, so actually, yes, when we wrote the RTC, RFC, we never considered the hierarchy route reflectors, right? So basically, the problem only happens in that case. And I think there are two solutions. Either don't override the originator, or do the add paths to send all the paths from top level to lower levels. And you're done, right?
Sure, there's multiple solutions. The solution we chose is the one that yes.
Okay, Jendo. I think in this picture should also consider the cluster ID, right? Because the route go up and they already have the cluster ID of the R3. When it goes down again, this route will be discarded.
Are you saying, so in this scenario, each route reflector has its own cluster ID. So then there's no actual cluster. If you make an actual cluster, then the problem doesn't happen.
Okay. And another thing is we know that there's another draft related to the RDC problem in the hierarchical R scenario. So maybe we can consider a general solution for both cases. And actually, in my opinion, this best path selection rules may not apply to this just family. Maybe we need another rule to consider for this.
I remember this one, Jim. I talked with you about that one those many years ago. I did consider this one again, but these are actually two separate problems with independent.
Because both drafts suggested some modification to the RDC path selection rules. Maybe there will be conflict if you don't coordinate, right?
Yeah, I know, and they're actually different rules, and the rules do not conflict each other.
Okay, we can talk offline.
Anchor Chen. So just a clarification. If you look at the route reflection draft, no, not the draft, as a spec, it actually has the text. Basically, say in the base path calculation, you need to prefer the ones actually with the shortest class list. That covers the case you favor the one you learned from the client directly. So when folks deal with the hierarchical or just a route reflection, you need to follow that.
It doesn't stop the problem. This route oscillation occurs anyway.
Jeff has I think for purposes of this presentation, it might have been good for us to do a review of why 4684 is doing the very strange thing that it does. Because most of the comments of the bike have been, don't do this, normal BGP doesn't do this. We agree, normal PGP does not do this. 4684 breaks the rules, and therefore we have this problem.
Okay, so let's see. This is for information. Is there what do you want to do with this thing? It's always interesting when somebody identifies a bug and then there's like a solution on the table, and it sounds like there's a couple other possible ones, and it would make me feel better if we then said, okay, and we're going to progress something.
Okay, asking for working group adoption for that solution, for the solution that we posted. This is the solution that we implemented, and it worked in the case. I'm sure other people can come with other solutions, and we can talk about those if we want.
All right. Thanks, everybody. That's a wrap. See you next time.
Anyway, I promised to reread your draft.
Yeah.
Oh, and I see one of the clipboards with the blue sheet. If somebody would bring up the other blue sheet to the front, that would be great. Thank you.
Somewhere in the middle, there's this bridge.